We're in Chapter 4, looking at bivariate data. And in Section 4.1, we're looking at correlation. So if we were to examine bivariate data, that means that we're looking at data between two variables whose data is paired. So if we have variables x and y, and suppose we have a point x1, well then we also have a value y1. And if we have a value x2, well then we have a value y2. And of course, we're always assuming we have a finite number of data points, but they're always going to be paired with each other. Now, one thing that we can do with each data point is look at it as, or I should say each set of data points is look at it as an ordered pair. I do want to write that word order because we typically say x1 first, then y1. And we look at this as a point on a plane, or if you prefer, a point on a graph. Right, so if you just think about this, maybe I'll move this over here. If we have our axes, right, this is our x-axis, our y-axis. If maybe this is the value of x1, maybe that's the value of y1, there's our point, right? That pair corresponds to that point. And we typically write that pair, right, as parentheses x1 comma y1. Right, and the same is true for all the other points, right? They might be somewhere on this plane, who knows? And what we do is we use this visualization to see if there's a possible relationship between the variables x and y. For example, looking at example 1, we have reading proficiency and math proficiency as a percentage of students in each state. And we want to see if there is a correlation between. We want to see if there is some kind of a relationship between them. If reading proficiency is high, then is math proficiency high, and vice versa? Is reading proficiency is low, then is math proficiency low? So what we can do is if we can visualize this data by going into Minitab in this case, entering the data, which I just copied it into Minitab, and if we go to Stat, Regression, Fitted Line Plot, and they give you the response variable first, the y variable. It doesn't really matter in this case, but if they give it to you as reading first and then math second, let's just stick with that. Keep everything the same, press OK. And if we take a look, they give us r squared, we'll get to that in a sec, blah, blah, blah. I can ignore those numbers. But if we just take a look at this graph, I'm trying to lower my thing. Oh, there we go. You can see that there does seem to be a relationship between reading and math proficiency, right? As reading proficiency is low, math proficiency tends to be low, and reading proficiency is middle, math proficiency tends to be middle on average, of course. And then when reading proficiency is high, math proficiency tends to be a bit high. Now, of course, this is on average. And it's not a perfect relationship, but there is a relationship there. Okay, and don't worry about the line for right now. Just note that we do have what appears to be a positive relationship between the two proficiencies. So if we can just go ahead and screenshot this. And we'll just maybe copy paste this. Right there. Blow this up a little bit. So not only did we see that there was a positive relationship, but we actually drew a line through them. Okay, so let's just write that down. There appears to be a positive relationship between reading and math proficiency. That is, I'll just say the points tends to follow a line, I'll just say roughly, with positive slope. Okay. So again, they were positively associated, right? Because again, the large values of x and the large values of y tended to go together. Small values of x tended to go with small values of y. So when that happens, we say that x and y are positively associated, right? As x increases, that implies that y increases, right? So an example of two variables that are negatively associated might be if x equals the age of a, let's say, a battery, and then y is life of a battery, right? If you take a battery that's brand new, it's young, its age is 0, right, or close to 0, and it's got a lot of life, right? But as it gets used repeatedly, as it just ages, its age increases, but its life decreases. So as x increases, that implies that y decreases, that y decreases, right? Negative relationship. Okay, now if the points on the line form a roughly line-like shape, then the variables have a linear relationship. So the question is, do the math and reading proficiency percentages, do they have a linear relationship? Yeah, it looks like roughly. I would say yes. Again, roughly. You're never going to get a perfect linear relationship. In real life, you almost never get a perfect linear relationship, but you get a relationship. So in each of these cases, let's take a look and see whether the relationship is positive or negative or non-existent. And if it is positive or negative, let's see whether it's linear or not. So let's use reds as well. So in this case, this relationship looks pretty linear to me. But note that it's negative, right? As x increases, y decreases. So we'll say negative and linear. Maybe I'll use lowercase. Okay. What about for B? Positive, not really linear, but kind of linear, right? You know, it's like somewhat linear, you could say, I guess. I'll say somewhat linear, right? And then in this case, I would say this is positive and linear. Right. What about for D? There's not really a relationship going on there. And then this last one, right, negative. There is definitely a negative relationship. I'd say somewhat linear, but it's not really. It's really more like in this shape, right? That would be a better type of relationship, but it's not completely not linear based on what we've got, right? And by the way, just to go a little bit more on Part D, the reason that Part D does not have a linear relationship is because, like, any of these lines seem to represent the trend, right? There's no clear trend based on a single line, okay? And that's all we've got for today.